Hello, students. Today we are going to go over 11.4b, explicit formula for arithmetic sequences. Now, our objective is I can use and write explicit formulas for arithmetic sequences. Now, when we worked on sequences before, it was always contingent on the previous term. And what we needed to do was find a way to get the answer for something that might be like the 50th term or the 99th term without having to figure out the 98th and the 97th, the 96th term, all of those. It made it difficult. So now we're going to learn this new formula where you can just jump to whatever term you want to find, and it's an easy formula to write down. It's a little bit complicated at first, but once you get it, you're going to be like, oh wow, this is so much easier than when you're going to find the 10th term to have to do the 2nd, 3rd, 4th, 5th, 6th, all the way to 10th. So, an explicit formula designates the nth term of the sequence as an expression of n, where n equals the term's location. It defines the sequence as a formula in terms of n. It may be written in either subscript notation, a to the n, which that is incorrect on that paper. It should be a with a little n, or in functional notation, f of n, a bigger n. So here we have this arithmetic sequence, 6, 10, 14, 18, 22, 26. Okay, so here's the function notation. Here's the sequence notation. This is the term number, and here are the terms. And here it is in graphic notation. So we have it in table, graph, or just a listing of numbers, a set of numbers. So the process of writing an explicit formula for an arithmetic sequence. First, you determine if this sequence is arithmetic, okay? So we go 6, what do you do to 6 to get to 10? 10 to 14, 14 to 18. Oh, I can see this. I add 4, add 4, add 4, add 4. Then I determine, yes, it is an arithmetic sequence. Okay? So then we find the common difference. We can see D is 4. Then we create an explicit formula using the pattern of the first term added to the product of the common difference and one less than the term number. Okay? So that sounds pretty complicated to me. So we'll break it down a little bit more. So we just say a to the n equals a to the first. Always list the first term, just like we did in sequence notation and functional notation before. Then what we have to do is put the first term again, a to the 1 plus d, what the common difference is, and then one less number. So we'll put n minus 1 there. So we'll go over a little bit more in detail on that. So our sequence notation is all of this. And function notation is all of this. Very, very similar, okay? So we're not going to, anyway, so the explicit formula for 6, 10, 14, 18 in both notation is a to the n equals 6. Again, you put the a1, so that's our first term with 6. Was 6 our first term up here? Yes, it was. And so we put 6 plus 4 times n minus 1 because our common difference was 4. Now we use our distributive property and go 6 plus 4n minus 4, and then we combine like terms. 6 minus 4 is 2. So a to the n equals 4n plus 2. Okay, so this is a sub n, but this is not any more sub numbers besides the first a sub n. Then this one, in function notation, it's the same thing where we list a1, which is 6, and then we add 4, that's the common difference, times the n minus 1. Multiply it out, and you see you get the same thing there. Now, to find this number 2 here and here, all you would have to do is go to the formula here and go backwards 1. So if I'm adding 6 and get to 10, then I subtract, or adding 4 to 6 to get to 10, adding 4 to 10 to get to 14. If I subtract 6, I get 2. And that's how you'll know what this number is here, right here, this 2. So a to the n equals 4, again the common difference, times n plus the number 2, which is going backwards or finding term 0 for the set, okay? So we are going to go ahead and go to our next video for the second part.